Hello viewers, in today's class we are going to solve yet another important and conceptual problem from definite integrals, right? So here we have to evaluate this integral from 1 to 3, and our integrand is signum function of x minus 2 divided by x plus fractional part of x, right? So here what we will do, will make use of the definition of signum function and the fractional part function, right? So let us start. Now let us first call this integral as I, right? Now before proceeding further, let us first take the definition of signum function, right? Now we know that the signum of y is equal to plus 1 whenever y is greater than 0, and signum of y is equal to 0 whenever y is equal to 0, and signum of y is equal to minus 1 whenever y is less than 0, right? So this is the basic definition of signum function, right? So now we have to apply this definition to this function, that is signum of x minus 2, right? So if we take y as x minus 2 and we write the definition of signum of x minus 2 on these lines, right? So signum of x minus 2 is plus 1 whenever y is greater than 0. So here we have x minus 2 is greater than 0, or this implies x is greater than 2, right? And here signum of x minus 2 is equal to 0 whenever y is 0. So here we have x minus 2 that is equal to 0. So we have x is equal to 2, right? And signum of x minus 2 is equal to minus 1 whenever y is less than 0. So for y we have x minus 2 is less than 0. So x is less than 2, right? Okay, so now here let us concentrate on this value, that is x is equal to 2, right? And here if we look at this integral, we see that the lower limit is 1 and the upper limit is 3, right? So here the lower limit is 1, the upper limit is 3, and between 1 and 3 we have the integer 2, right? So all those values of x which lies to the left of 2 are less than 2, and here we have x is equal to 2, and all those values of x which lies towards the right of 2 are greater than 2, right? Okay, so now making use of this definition of signum function, we can rewrite our integral I as 1 to 2, because here we have to break this integral I as a sum of two integrals, that is I is I1 plus I2, right? So I1 varies from 1 to 2, and we have a signum of x minus 2 over x plus fractional part of x dx, and here we have 2 to 3 and signum of x minus 2 over x plus fractional part of x dx, right? Okay, so now we have 1 to 2, and when x varies from 1 to 2, x is less than 2, right? So when x is less than 2, then signum of x minus 2 will take the value minus 1. So here we have minus 1 over x plus fractional part of x dx, and then we have 2 to 3. So when x varies from 2 to 3, it means x is greater than 2. So signum of x minus 2 is plus 1 when x is greater than 2, right? So here we have plus 1 over x plus fractional part of x, right? Now let us apply the definition of fractional part function, right? So here we have the fractional part of x, and we know that the fractional part of x can be written as x minus greatest integer of x, right? So if we replace fractional part of x by x minus greatest integer of x, we have 1 to 2, then we have minus 1 over x plus x minus greatest integer of x dx, and here we have 2 to 3, and here we have 1 over x plus x minus greatest integer of x, and here we have dx, right? So now we have 1 to 2, and we can take this negative sign outside, so we have dx over 2x minus greatest integer of x, and here we have 2 to 3, and we have dx over 2x minus greatest integer of x, right? So now we have to assign the value to this greatest integer of x, right? So let us first see this integral. So when x, it varies from 1 to 2, right? See, this integral varies from 1 to 2. It means we have to integrate from 1 to 2, right? So when x lies between 1 and 2, then the value of greatest integer of x is equal to 1, right? And when we take this integral, that is x varies from 2 to 3, then the value of this greatest integer x is simply 2, right? So now we can write here 1, and here we can write 2. So we have now minus 1 to 2, and we have dx over 2x minus 1, and here we have 2 to 3, and dx over 2x minus 2, right? So now viewers, we have two simple integrals here, right? Very simple integrals, and here we'll make use of the result, that is integral of dx over ax plus b is equal to 1 over a log of ax plus b, right? So this result would be used to find the integral of this function, that is 1 over 2x minus 1 and 1 over 2x minus 2, right? So I can be written as minus, and here we have 1 over 2, because here a is 2, and we have a log of 2x minus 1, and the limits are from 1 to 2, and here we have a is again 2, so we have 1 over 2 and log of 2x minus 2, right? 2x minus 2, and the limits of integration are from 2 to 3, right? So now we have to just substitute the limits here, and we'll take the difference. So we'll take this first term, so we have we can take half outside, so we have minus half, and when we take x is equal to 2 here, so we have log of 4 minus 1, that is a log of 3, and here if we take x is equal to 1, so 2 minus 1 is 1, right? So we have log of 1, and here again we can take half outside, and when we take x is equal to 3 here, so 3 to the 6, 6 minus 2 is 4, that is 3 to the 6 minus 2 is 4, right? And minus, when we take x is equal to 2, we have a log of 4 minus 2, that is log of 2, right? So now we can write minus half, and log of 1 is equal to 0, so we have simply minus 1 over 2 log of 3, and here we have half, and log of 4 can be written as 2 log 2 minus log 2, and this is minus half log 3, and here 2 log 2 minus log 2 is log 2, so we have half of log 2, right? Now we can take half outside, So we have log of 2 minus log of 3, and by this property, that is log of m minus log of n is equal to log of m over n, we can write half log 2 over 3, right? So viewers, the value of this integral is equal to half log 2 over 3, right? And this expression can also be written as the log of square root of 2 over 3, right? So this is how we solve this integral.